Okay, YouTube, in my last video we introduced the concept of the quadratic formula for solving quadratic equations in standard form set equal to 0. In this video we're going to look at a couple of instances in which we use the quadratic formula that lead us to some interesting solutions cases. So you'll notice that I've already labeled these, one having one real solution, the other one having no real solution. So let's go ahead and take a look at both of these and discuss what the implications are of their solutions, if they exist, and their graphs. So we'll say we'll solve this first quadratic equation using the quadratic formula, which means that the first thing we're going to need to do here before we do anything else, this 4x squared plus 3x is equal to negative 13x minus 16. We're going to need to set this equal to 0. So what I'm going to do is I'm going to bring this negative 13x back over here and this negative 16 over here, which would make this a 4x squared plus 16x's total plus 16 constants. This would be equal to 0. So let's go ahead and start by identifying what our A, B, and C are in this situation. We would say that we have 4, looks like 4, 16, and 16. Okay. So now looking at this, we'd say, well, then the solutions would have to follow the quadratic formula, which is negative b plus or minus the square root of b squared minus 4 times a times c, and this is all over 2 times a. So we'll start by placing our b value in here. So we'd have 16 and 16. Our a value here in this case is 4, and then we also have 4. And then we put another, let's see, 16 is our c value. Yes, indeed. So we're going to get this. We're going to get x equals negative 16 plus or minus, and this is all over 2 times 4, 8. So now we'll work on what's inside this radical here. We say 16 squared. You can look this up on your calculator, but I'd say it's 256. I noticed that a negative times a positive, only one negative means that the whole product will be negative. And 4 times 4, which is 16, we're going to get 16 times 16 again, which is 256. So the important thing to recognize here is that we are led to this fact that we get negative 16 plus or minus the square root of 0 all over 8. And so our two solutions, just to be clear on this, we do have two solutions. We get negative 16 plus the square root of 0 over 8, and we get negative 16 minus the square root of 0 over 8. What makes this significant, though, is the fact that the square root of 0 is 0. So we would really get negative 16 over 8 here and negative 16 over 8 here, which leads us to the fact that we get negative 2 and negative 2. So I want to talk about what would this mean about your graph if the only x-intercept or 0 that it has is negative 2. And I think that that would mean that the only part of this parabola that could be touching the x-axis at negative 2 is its vertex. So you'll notice that I've already put in this equation and also the equation for the next one, but we have this parabola that opens upward with an a value of 4, of course it would, but also that I would indicate its only 0 is negative 2 here, and that was the same thing we found using the quadratic formula. So whenever you get what's inside the radical to come out to be 0, what you have to understand is that you're not going to get two answers that are real. You're going to get one answer twice, and it's going to be a real answer, okay? So now let's take a look at this equation down here, 5x squared plus 2x minus 1. And the very first thing that I'm going to do is I'm going to bring that negative 1 back over to the left side here so that we have it set equal to 0. So now we're set up to use our quadratic formula. We can identify a, b, and c in this standard form. And it looks like, respectively, we have 5, 2, and 1 for our a, b, and c values. So let's go ahead and drop this into our quadratic formula. We have negative b plus or minus the square root of this b squared minus 4ac all over 2a. And again, we'll drop in our values here. We have b and b, so we have 2 and 2, and then a and a here, where our a value is 5, and then we have a 5 here. It looks like our c value is 1. It's going to make our job a little bit easier on the inside. So simplifying this, looks like we have a negative 2 plus or minus some number in the square root here all over 10. So inside the square root, inside the radicand here, we would say 2 squared is 4. And because I have one negative in this entire product of 3 factors over here, the whole thing is going to be negative, and 4 times 5 times 1 is 20. So what we end up with here is this. We get negative 2 plus or minus the square root of negative 16 all over 10. And recall, when you take the root, or at least the square root of a negative here, the very first response we should have is to put an I out front. And then just treat this the same way we would with a regular square root, which, by the way, we know the square root of 16, or we should know it, is 4. We're going to say negative 2 plus or minus now I times 4, which is 4i, all over 10. And because these are all factors of 2, or at least 2 is a common factor to each, we're going to divide each one by 2. We're going to get negative 1 plus or minus 2i, and this is all over 5. So our two roots here are these. We say negative 1 plus 2i all over 5, and negative 1 minus 2i all over 5. So the fact here is this. We say these are non-real zeros, which means it's never going to touch the x-axis if we go and draw a graph of this. So graphical significance here. I basically wanted to take a look at this. We could see that we could have, if we graphed this first, told you right now you're not going to get any real solutions because there are no x-intercepts for this graph. But using the quadratic formula, what I want you to recognize is, well, you know you're going to get imaginary solutions if what is inside the radical here comes out to be a negative value. Cheers.